Hi guys, so this is the lesson for 6.3 and this is our second part to solving trig equations. So this is different than last time because, well, these are a little bit harder, so don't get mad. But also, a lot of the times we're going to have something crazy happening to our x's. So it could be dividing it by 2 or 3 or 5 or whatever, or we could be doubling it like over here. That creates more or less answers depending on if it's halving it or doubling it. And sometimes we have to do different things because like here we're not in the same argument. We have 2x and x, but those angle things have to be the same. Okay, so that's going to make us use some of our identities to get them the same. And it also changes our domain of our function. So we're doubling our domain or splitting our domain in half, so we might not have as many answers, or we might have twice as many answers. So let's get started and see what really is going on here. Okay, so before we try to solve this, let's look at our domain. This is saying that x is divided by 2. So our domain, or the interval we want our solutions in, is from 0 to 2 pi. So what that is saying is that we want x to be between 0 and 2 pi. But what we have over here is that x is, it's not plain x, it's x over 2. So we're splitting this in half. We're dividing everything by 2 and dividing our domain in half. So we have that when we're solving for x over 2, it's restricted from 0 to pi. Okay, so if you think about what we have sine. That's not really cutting any answers out, but for cosine it would be. So let's solve it like what we did last class. So we would first divide by 2, and then we have that sine of x over 2 equals 1/2. Okay, so where does sine equal 1/2? Well, that's when we're in quadrant 1 and 2. So it has a reference angle of 30. So x over 2 equals 30 in quadrant 1 and 150 in quadrant 2. But are we done solving for x? No, we're not. We have x over 2, not just x. Okay. Before we finish solving, just at this point, you have to check and make sure your answers are between 0 and pi. So they are, so we don't have to get rid of any. But that would be where you would cut out some answers. Okay, so to solve for x, we times by 2. So if we do that, we get that our x is equal to 60 and 300. Our interval set was in radians, so we need to change these to radians. So 60 is pi over 3, and 300 is 5 pi over 3. So those would be our two solutions for that. Okay, so why don't you try the one at the bottom? Okay, so remember what we're doing to our domain. We're splitting it in half. So since this is cosine, it's going to change some stuff. So go ahead and pause and find the solutions to this, and then when you come back, I'll help you with it. Okay, so remember we have half as big domain. It's from 0 to pi now. So when I solve this, I get that it equals root 2 over 2, which is the same thing as 1 over 2, 1 over root 2. It's positive, so we're in quadrant 1 and quadrant 4. So if it's 1 over root 2, we get a reference angle of 45. But since we can only go to 0 to pi, which is quadrants 1 and 2, I can't have this answer of 315 because it's bigger than what our restricted domain is. Okay, so that means our only answer would be this one, and if we solve for x, we get 90 or pi over 2. So remember we talked about how this is going to cancel out some answers sometimes because they're bigger than where our answers are allowed. Okay, so let's try some on the other side. So this one's different because, like I said before, we have cosine of 2x and cosine of x, but we need them to be the same thing. We can't have a 2x and an x. Okay, so we can use our identities to get them to be the same. So if you look at your double angle identities, we have that cosine of 2x is equal to 2 cosine squared of x minus 1. So that's the one we're going to use. And I picked this one because we have cosine over here. I don't want to pick the one with sine because then I'm going to be stuck with a sine too, and I want just one function and one angle measure. So change this to 2 cosine squared minus 1 equals cosine x. And now we can solve for x. So what would we do? Very good. Move everything over. So 2 cosine squared x minus cosine x minus 1 equals 0. So this is one where we have to factor. Factors a negative 2 that adds to be negative 1. So negative 2 that adds to be negative 1 would be negative 2 and positive 1. Remember, we put the 2 in both of them. Okay, we can reduce this out by dividing it by 2. So we would have cosine of x minus 1 equals 0. 2 cosine of x plus 1 equals 0. And then we do what we did before. Since we got rid of the 2x, we don't have to worry about our interval because we changed it to regular x, so it's not doubling it or halving it. So if we solve each one, cosine of x equals 1, that means that x is 0. Here we get cosine of x equals negative 1/2. So cosine's negative and 2 and 3. That equals 1/2 with a reference angle of 60. So x would be 120 and 240. But again, we were in radians, so we need to change these to radians. So that would just be 0 radians, 2 pi over 3, and 4 pi over 3. And that's it. Okay, so why don't you try the bottom one? It's just like what we just did, except we want sines instead of cosines. So when you use your double angle identity, use the one that's going to get cosines. Or get sines, not cosines. Okay, so we use the sine one. I moved everything to the right side to make that squared positive. I mean, you could have put it on the left and multiplied by a negative 1. So from the first half we get 270. The second half is 1/2, so 3 and 150. And then I changed them all to radians. Remember, write down if you have questions. If you didn't understand something that happened in that one. Okay, so let's move on to page 3. So what's going on with this one? Well, luckily we can leave our answers in degrees, so we got that. But the problem with this one is that we have different functions. Okay, so when you're trying to solve these equations, the first things I would look for are, do they have the same function? Are they all sines or all cosines? And do they have the same argument? An argument is another word for angles. So they're both just plain theta, so that part's okay, but they're not the same function. So we can use our Pythagorean identity and change either the sines or the cosines, it doesn't matter. I'm going to change the cosines to the sines. So I know that cosine squared is equal to 1 minus sine squared. So I would have 2 times 1 minus sine squared minus 2 sine squared from what we had here plus 1 equals 0. So if I distribute and do my normal equation stuff, combine like terms. So we have negative 4 sine squared plus 3 equals 0. So this is almost pretty much a two-step equation. So subtract 3 and divide by negative 4. So we would have sine squared of theta equals 3 over 4. And then to get rid of the squared, take the square root. So we have sine of theta equals, remember when you're square rooting an equation, you always have plus or minus. The square root of 3, we can't do that, so it stays. The square root of 4 is just 2. So we get that sine theta equals plus or minus root 3 over 2. So from here we can draw our triangles and figure out those angles. Since it's plus and minus, we're going to be in positive quadrants and negative. So we're really in all 4 quadrants now because it's positive and negative. We get our cool bow tie. So cosine is root 3 over 2. So that means that we have a reference angle of 60. So in quadrant 1 it would be 60. Quadrant 2, 180 minus 60. Quadrant 3 is 180 plus 60. quadrant 4, or I said quadrant 2, quadrant 3, and then quadrant 4 is 300 minus, or 360 minus 60, which is 300. And since our interval at the top was in degrees, we can leave our answers in degrees, just like that. Okay, good job. So let's take a look at our next problem here. So this is kind of like our problem that we had in the last set of notes, in that it's secant and tangent. So we need to square them like we did to get them to be the same function. But remember, we have to FOIL it out. So if we square this side the way it is in FOIL, then we're still going to have some pieces that are not squared, and then we'll still have a tangent or a secant depending on how we want to change it. So what I'm going to do is I'm going to move one over to the other side. I'm going to choose the tangent. We really could have done it either way. Okay, so now I have secant of 3x equals 2 minus tangent of 3x. So just like what we did in 6.2, we're going to square both sides. Poor purple pen is dead. Okay, so square both sides. And on the right side, you're going to have to FOIL. So this gives us secant squared 3x equals 4 minus 4 tangent of 3x plus tangent squared 3x. So since I have all these tangents over here, that means I'm going to change this to a tangent. So secant squared equals tangent squared plus 1. So now we can combine like terms. Luckily, our tangent squareds are going to cancel out. So if I subtract 4 from over here, I'll get negative 3. And then if I divide by that negative 4, I'll have positive 3/4. So tangent of 3x equals positive 3/4. So again, these canceled out. I subtracted that 4, and then I divided by that negative 4, which is where I got this. Okay, so before we keep going, I want us to go back to the beginning. Okay, we didn't talk about this up here, but it says that our interval is for normal x is from 0 to 2 pi, but we don't have normal x, we have 3x. So that means we're going to have to times our interval by 3. So that means we can have answers that go up to 6 pi. Okay, so that means we're going to have more than just 2 answers. Okay, so let's figure this out. So we're in radians, so that means we're going to want to change our mode to radians on our calculator. Okay, and then we'll solve for a tangent by doing the inverse. So tangent inverse 3/4. So I get 0.6435. I know this would be easier in degrees, but we don't have degrees. So that means that we have that 3x equals 0.64. Well, I'll do 4.35. So that's our positive one in quadrant 1, but remember we're in quadrant 1 and quadrant 2. So I have this one, and now I need to get this. So remember in quadrant 4, it's 180 plus our reference angle, but since we're in radians, we wouldn't add 180, we would add pi. So I'm going to add pi to that answer. So my value for quadrant 4 is 3.7851. So for right now, we only have quadrant 1 and quadrant 4, but I can go all the way up to 6 pi with our interval. So that means I'm going to have to add 2 pi to this and see where it's at. Okay, before we do that, I want to, so that means our answers can be from 0 all the way up to 18.85. Okay, so until I get to a number that passes 18.85, I need to add 2 pi. So remember, that's like adding 360. We're going around and around and around. Okay, so first I'm going to add 2 pi to my answers that I have. Okay, so 0.6435 plus 2 pi gives us 6.9267. So I'm still under 18, so I'm going to add 2 pi again. So plus 2 pi. Oh, I totally messed that up. Okay. 0.6435 plus. So we would get 13.2099. If I try to add 2 pi again, I get bigger than my interval, so I have to stop. Okay. So now we'll do the same thing over here. So take this one, add 2 pi, and then add 2 pi to that. So with those, we have 10.0683 and 16.3515. Okay, so those are going to be our 6 answers, but those are our answers for 3x, and we need to find just x. So now what we're going to have to do is take all of those numbers and divide them by 3. Okay, so once you divide by 3, you get these 6 answers. And I know that that would have been a lot easier if we were in degrees, because then we wouldn't have, well, I mean, we'd still have decimals, but I think it makes more sense in degrees. Okay, so we had to have all these answers because our interval increased because it said 3x instead of just x. So let's try another one. Okay, so I know the video is getting long. We'll stop soon. Let's do the one on page 5. And then remind me, and we'll go over the example on page 6 in class. So when we look at this, we have sines and cosines again. Neither of them are squared, so we can't use the Pythagorean identities. But does this look like one of our identities that we have? Very good if you said the double angle identity. But the double angle identity says 2 sine cosine. So what we're going to do is I'm going to break up that 4 into 2 times 2. Because now we'll have our 2 sine cosine, and we can use our double angle identity. Okay? Because if we look on our identity sheet, 2 sine cosine equals sine of 2. So I'm going to replace this with sine of 2x, or theta, whatever. So now we have 2 times the sine of 2 theta equals root 3. So remember, doubling this doubles this. So we really are going to be from 0 to 720. Okay? So if we solve for sine of 2 theta, we divide by that 2, and we get root 3 over 2. So sine is positive in quadrant 1 and 4, and this will have a reference angle of 60. So 2 theta equals 60, and in quadrant 2, we'd have 120. But since we're 2 theta, we got to go all the way up to 720. So that means we're going to take another trip around the circle and add 360. So 60 plus 360 is 420. And then 120 plus 360 is 480. And if I add 360 to either of those again, I get outside of my interval, so I can't add again. I mean, this really tells you how many times you can add. Okay. Since it's doubling it, we're going to have like double the amount of answers. The last one, it was tripled, so we had 3, so we had to add it twice. So now we just have to divide everything by 2 to get just theta. So theta equals 30, 60, 210, and 240. And that's it. So this is like what we did on page 4, except it wasn't all those decimals, so it made it like 100 times easier. Okay, so again, remind me to do example 6 in class. Warner out.